Hi, I'm Dhanraj Jadhav from Team Data Miners. Our problem statement ID is problem statement 2 and problem statement title is create an API gateway to run SQL queries on survey dataset and retrieve the result in user-friendly form like JSON or CSV. Our problem statement category is software and team ID is 7374 43 sorry. So the problem statement was there are MoSPI microdata. Basically, it is a survey data, and accessing that data set is inefficient and requires large amount of large file downloads and manual filtering or handling the inconsistent data format. So to overcome this problem, we came up with an idea, in which a user can run a SQL query on that data set and it get the data set in a user friendly format. To run a SQL query, first of all, we need the data to be present in a relational database on which we can run SQL query. To transport the MoSPI microdata to relational database, we have made an ETL pipeline which loads the MoSPI microdata to the relational database by converting the raw MoSPI data to a specific format and then uploading to the relational database. And it is also has a role based access for the API. Let's say, for example, admin can access the ETL pipeline and a complete SQL query running API as well, but a user, a guest or a researcher can access only API of running the SQL query. uh, what are the innovation and the uniqueness in our solution? The first uniqueness is that we are also implementing real-time analytics tool which are open sources, and we are also implementing integrating BI tools which will enable the user to see the data in a visual format. We are also going to integrate the AI which enhances our queries by understanding the user intent and optimizing the result. The technology stack we are going to use to make we have used is React, Postgres for relational database, React for front end, AWS RDS for hosting the relational database. We can also host the Postgres database on premise. Python for ETL pipelines and Node.js for backend. GitHub for managing the version of our solution. So this is the basic workflow of our solution. This is the data ingestion pipeline, that is ETL pipeline. Here admin can upload the raw data set of MoSPI surveys, and our ETL script or ETL pipeline will convert that raw data to a relational database format, that is a structured tabular format. And then from here, API client or a dashboard UI, everyone can access the data by running a SQL query or on the relational databases. So a user can access the data based on their roles, whether it is premium model or it is a free model, and based on they can access their data. We made an API layer on the top of that relational database. We have also implemented ETL pipelines which convert the raw data to relational databases. For sustaining the solution, we have introduced micropayment method, which cost recovery mechanism, which basically provides a cost recovery mechanism, and also implemented rate limiting method which can be used in scalable architecture. And our main goal was just not to make a solution but to make a scalable architecture which can scale on a large scale and can be implemented by other um, government ministries as well. What will be the potential impact? The potential impact will be everyone can access the high precision data or the survey data, we can say. There will be a centralized and a streamlined download and data cleaning process, and the remote access of the data. Researchers, or as we know India is a democratic country, so the survey data should be open source and can be accessed by every citizen, which will leads to the democratized data access, which can be accessed by journalists, researchers, NGOs, or for student or for research purposes. And we have as the data is open source, various developer or businesses can make tools on top of that data, like commercial tools or AI models powered by MoSPI data. Element repeats large data set downloads, lowering storage and bandwidth needs. Basically, large data sets are redundant and they store the information in a repeated format, which is eliminated by our solution. So these are the reference links which we have reference for making our solution. This is our GitHub repo, you can visit it, and this is a prototype of basic version 0. As we can visit it, we have here two data sets available. First one is periodic label for survey 2019, from July 2019 to June 2020, and another one periodic label for survey from July 2018 to July 2019. As we visit the PLFS survey from July 2019 to July 2020, we can see two data tables. One is HHFV and another one is HHRV. We can visit any one of it. Let's, for testing purpose, visit the HHFV 2000. Here we will enter our SQL query, and one thing we have to consider is we have to use this as a table name in our SQL query. We are going to limit the data. As data is huge, we are going to limit it for 100 entries only. As we can see, we have successfully fetched the data, and this is MoSPI data which is provided in raw form. We have implemented an ETL pipeline which inject that data into relational database, and then we have implemented a API layer on top of that database so we can access the data. And this is a JSON view of the data. We are going to extend our solution on role based action. We are going to implement scalable architecture integrating AI. So this is just a basic version 0, and so that's all from my side. Thank you.